On our previous lesson, we talked about making a stock solution for we to create a concentration of a particular solid. Like for example, we use Kool-Aid, we weighed it up, and then we able to actually get the concentration by actually adding our specific solvent, which in our case we use water, and we made the water to reach this particular white line, which is this particular red line right there. And from there, from our specific volume of this particular volumetric flask, which is 250 mils, we're able to actually use two variables, which are first the mass of our Kool-Aid and the volume of our solvent, which is in this case water. Now once we consider those, we could actually determine the concentration of our solution. However, Kool-Aid is kind of hard to determine, it's molecularly, so it's pretty hard to identify or determine the moles of a Kool-Aid in order for we to make our concentration to be in moles per liter. Now this here that we've made is called our stock solution, and from our stock solution we can actually make dilutions of this particular solution. And I know that one of you actually made a great point, which is that hey, to make a stock solution we have to add more volume in there. So to add more volume, what do you think is going to happen? It means that as I increase the volume, my concentration, which is C1, would decrease going into C2. And that is where we have our C1 V1 equals to C2 V2 comes into play, coming from our stock solution into our dilute solution. Now for dilute solutions, sometimes you'll be, or most times you'll be given the volume, and then you'll be asked what is the concentration of this particular solution right there, which is C2 right there. So once you make your stock solution, the same process, all you have to do in here is pipette out a specific volume out of this particular stock solution, and then from that volume you add it into this particular volumetric flask, which is a new one, and then you make it up to the new volume of this volumetric flask up to this particular ring, which is where the meniscus of this liquid actually touches. And then you can be able to know that hey, if the total volume is 250 mils, and then I'm taking out a specific volume which is V1 out of this particular solution, and I know the concentration of this solution, I can actually determine the new concentration of this particular solution, where I know the final volume of this particular solution based on this particular volumetric flask label right there. So in that case, to determine that, all I need to do is you find the equivalence of this, which is C1 V1 equals to C2 V2, where our C1 is equals to the concentration initial, or I'll say initial concentration, which is measured in moles per liter, and then C2 equals to the concentration final, same unit, mole per liter, then V1 is equals to the initial volume, which is how much volume you took out of the stock solution, measured in liters, and finally V2 is the final volume of your new solution that you created, which is this particular mark right there, the meniscus line right there, where you added water to this V1 in here to make it up to the meniscus line. And this is our final volume, which is measured in liters. So from here on, you can actually solve this particular problem, which is all the way down. So that's about it for this particular video. Please let me hear your thought about this. You can solve various examples. There'll be more problems given to you, and stay smart, believe in yourselves.